You're holding your phone right now, feeling its weight, its smooth surface against your fingertips. Every atom in that device, every carbon molecule in your skin, every oxygen particle flowing through your lungs at this very moment, none of it should exist. According to the fundamental laws of physics, we should be living in a universe of pure energy, where matter never formed, where complexity never emerged, where you and I would never have come into being. And yet, here we are. The question that has haunted physicists for decades is deceptively simple. How did we get something from what appears to be nothing? How did the raw energy of the early universe transform into the intricate atomic structures that make up literally everything around you? Tonight, we're going to unravel one of the most profound mysteries in all of science. The story of how atoms, those invisible building blocks of reality, emerged from the cosmic void. Now, I know what you might be thinking. This sounds like heavy science, complex equations, the kind of stuff that puts you to sleep in textbooks. But here's the thing. This isn't just abstract physics. This is your origin story. Every single atom in your body was forged in conditions so extreme, so violent, so unlikely, that the very fact you're conscious and wondering about this right now borders on miraculous. What we're about to explore will challenge everything you think you know about how reality works. We'll dive into moments when the universe was smaller than the period at the end of this sentence, yet contained all the energy that would eventually become every star, every planet, every living thing that has ever existed. We'll witness the cosmic dance of forces so fundamental that they literally shaped the architecture of existence itself. If you find comfort in these gentle explorations at the intersection of science and mystery, I'd be grateful if you'd consider subscribing or hyping up this video with hype points. The visuals are here for you, but feel free to close your eyes, breathe deep, and let your imagination drift through these quantum possibilities. Also, I'd love to know where you're contemplating from tonight. Comment your time and location below. Let's begin. Before we journey back to those first incredible moments, let me tell you why this story matters more than you might realize. See, understanding how atoms formed isn't just about satisfying scientific curiosity. It's about grasping the most important truth of your existence. You are not separate from the universe. You are the universe. The calcium in your bones, the iron in your blood, the carbon that forms the backbone of your DNA, all of it emerged from processes so extraordinary that they make the most imaginative science fiction seem mundane by comparison. The journey we're about to take spans nearly 14 billion years, from the first trillionth of a second after the Big Bang to the moment complex atoms became stable enough to eventually form molecules, then cells, then consciousness capable of pondering its own existence. And here's what's truly mind-blowing. This entire cosmic symphony of creation happened according to rules so precise, so perfectly calibrated, that if any of the fundamental constants of physics were different by even the tiniest fraction, atoms would never have formed at all. Let me give you a preview of just how incredible this story becomes. In the beginning, there were no atoms. There weren't even the building blocks that would become atoms. The universe was a seething ocean of pure energy, so hot that particles couldn't hold together for more than an instant before being torn apart by the cosmic violence surrounding them. Yet within the first few minutes of existence, through a series of events that required perfect timing and impossible precision, the first simple atomic nuclei began to emerge from this chaos. We're talking about hydrogen and helium, the simplest possible atoms. But even these required conditions so specific that they could only exist within a narrow window of cosmic time. Too early, and the universe was too hot for anything to stick together. Too late, and the expanding cosmos would cool beyond the point where nuclear fusion could occur. The window for creating the first atoms lasted mere minutes in a universe that would go on to exist for billions of years. And that's just the beginning, because those first simple atoms would eventually give birth to stars. And inside those stellar furnaces, under pressures and temperatures that dwarf anything we can create on Earth, heavier elements would be forged: carbon, oxygen, nitrogen, iron. The periodic table we memorized in school represents a cosmic cookbook, with each element requiring its own specific recipe of temperature, pressure, and time to come into existence. But here's where the story gets really wild. The atoms that would eventually form you didn't just appear once and stay put. They've been recycling through the universe for billions of years. The carbon in your cells was created in the core of a dying star that exploded long before our solar system existed. The oxygen you're breathing right now has been part of countless other molecules, other organisms, other worlds. You are literally made of recycled stardust that has been on an incredible journey through space and time. Tonight, we're going to trace that journey from the very beginning. We'll start in the first moments after the Big Bang, when the universe was nothing but an expanding fireball of energy. We'll watch as that energy began to cool and condense, allowing the first particles to form. We'll witness the cosmic battle between matter and antimatter, a war that nearly resulted in a universe with no atoms at all. We'll explore the mysterious process of nucleosynthesis, when the first atomic nuclei were welded together in the cosmic furnace of the early universe. Then we'll fast forward through the Dark Ages, that long period when atoms existed, but stars had not yet formed to light up the cosmos. We'll see how gravity worked patiently to pull atoms together into the first stellar nurseries, where new elements would be cooked up in nuclear reactors millions of times more powerful than anything humans have ever built. But this isn't just a story about physics and chemistry. It's a story about emergence, about how simple things can combine to create complexity beyond imagination. Each step in atomic formation opened up new possibilities that didn't exist before. When hydrogen and helium first formed, they made possible the birth of stars. When stars began fusing heavier elements, they made possible the formation of planets. When planets formed with the right chemical ingredients, they made possible the emergence of life itself. And here's the part that should give you chills. This entire process, from the formation of the first atomic nuclei to the complex molecules that make up your brain, happened without any conscious guidance or design. The universe discovered how to create atoms through pure trial and error, through the relentless application of simple physical laws over vast spans of time. What we're looking at is creativity on a cosmic scale. The universe literally inventing new forms of complexity through the patient accumulation of simple interactions. The more we understand about atomic formation, the more we realize how precarious our existence truly is. There are so many ways this story could have gone wrong. If the strong nuclear force was slightly weaker, atomic nuclei would fall apart. If it were slightly stronger, hydrogen would be consumed so rapidly that stars couldn't form. If the electromagnetic force had a different strength, electrons couldn't orbit nuclei in stable patterns. The universe seems to exist in a narrow band of possibility where atoms can form, where complexity can emerge, where consciousness can eventually ask questions about its own origins. Some scientists call this the fine-tuning problem. Others see it as evidence of a multiverse, where countless universes exist with different physical laws, and we simply happen to live in one where atoms are possible. But regardless of the explanation, the fact remains that we live in a universe exquisitely calibrated for the formation of matter, for the emergence of complexity, for the development of structures that can eventually wonder about their own existence. What we're about to explore together will take us to the very edges of human knowledge. We'll encounter concepts that push against the limits of what our minds can comprehend. Temperatures so high that they defy imagination. Densities so extreme that a teaspoon of early universe matter would weigh more than a mountain. Time scales so brief that entire cosmic epochs pass in less time than it takes light to travel the width of an atom. But don't worry if some of these ideas seem overwhelming at first. The universe itself had to learn how to make atoms through billions of years of experimentation. We're going to follow that same journey, step by step, from the simplest beginnings to the most complex outcomes. By the time we're finished, you'll understand not just how atoms formed, but why their formation represents one of the most significant achievements in the history of reality itself. So settle in for a journey that spans the breadth of space and the depth of time. We're about to witness the birth of matter itself, the emergence of structure from chaos, the cosmic process that transformed pure energy into the building blocks of everything you've ever seen, touched, or imagined. This is the story of how the universe learned to create atoms from nothing, and in doing so, made possible everything that would follow, including the remarkable fact that you exist to contemplate this incredible tale. The adventure begins now, in the first moments after the Big Bang, when the universe was about to attempt something that had never been done before. The creation of matter from pure energy, the birth of atoms from the cosmic void. In those first impossibly brief moments after the Big Bang, the universe was nothing like the cosmos we observe today. There were no galaxies spinning majestically through space, no stars burning with nuclear fire, no planets orbiting in predictable patterns. Instead, imagine a realm so alien, so fundamentally different from our current reality, that every assumption you might have about how matter behaves simply didn't apply. The temperature was beyond comprehension. We're talking about conditions where the universe was over 1 trillion degrees hot. To put that in perspective, the core of our sun reaches about 15 million degrees, and that's hot enough to fuse hydrogen into helium through nuclear fusion. But in those earliest moments, the cosmic temperature was so extreme that even the fundamental particles that would eventually become atoms couldn't maintain their individual identities. Picture a cosmic soup, where energy and matter were completely interchangeable, where particles popped into existence only to be instantly destroyed by collisions with other particles moving at nearly the speed of light. This wasn't just hot, it was violently chaotic. Every cubic centimeter of space contained more energy than exists in entire galaxies today. The universe was essentially a bubbling cauldron of pure possibility, where the normal rules of chemistry and physics were suspended in favor of something far more primal. But here's where things get really interesting. Even in this cosmic chaos, the seeds of order were already being planted. As the universe expanded and began to cool, different types of particles started to emerge from the energy-rich environment. First came quarks, those fundamental building blocks that would eventually combine to form protons and neutrons. But in these early moments, quarks couldn't stick together. The temperature was still too high. the environment too violent for any stable structures to form. Think of it like trying to build a house during a hurricane while someone keeps throwing dynamite at your construction site. Every time particles tried to bond together, the intense heat and constant collisions would tear them apart almost instantly. The universe was essentially at war with itself, with the forces of creation and destruction locked in a cosmic battle that would determine whether matter could ever exist at all. As the expansion continued and temperatures began to drop, something remarkable started to happen. The quarks began to find each other and stick together, forming the first protons and neutrons. This process, called confinement, was like the universe suddenly discovering how to make the first stable building blocks. But even these protons and neutrons weren't safe yet. The environment was still far too hostile for anything resembling an atom to form. Here's where the story takes a dramatic turn. For the universe to create atoms, it needed to solve a fundamental problem that seems almost impossible to overcome. You see, when a proton and electron try to come together to form a hydrogen atom, they need to exist in a relatively calm environment where they won't be immediately torn apart by high-energy collisions. But the early universe was anything but calm. The solution came through one of the most elegant processes in cosmic history. As the universe continued to expand, it was essentially diluting its own energy. Imagine taking a drop of incredibly concentrated heat and spreading it across an ever-increasing volume of space. The temperature had to drop to just the right level where atomic nuclei could form, but not so low that the nuclear processes would stop working entirely. This is where we encounter one of the most crucial windows in cosmic history. Scientists call it Big Bang nucleosynthesis, and it lasted for only about 20 minutes. 20 minutes out of nearly 14 billion years of cosmic evolution. And yet during this brief window, the universe accomplished something extraordinary. It created the first atomic nuclei. The process began when protons and neutrons, those building blocks that had formed earlier, started sticking together through the strong nuclear force. But this wasn't random. The universe had to maintain exactly the right conditions for nuclear fusion to occur. Too hot, and the newly formed nuclei would be blasted apart by high-energy photons. Too cool, and the particles wouldn't have enough energy to overcome their electrical repulsion and fuse together. During these 20 minutes, the cosmic nuclear reactor was working at full capacity. Protons fused with neutrons to create deuterium, a heavy form of hydrogen. Deuterium nuclei then combined with additional protons and neutrons to form helium-3 and helium-4. Some small amounts of lithium were also produced. But here's the crucial point. The universe couldn't make anything heavier than lithium during this period. The conditions weren't right for forming carbon, oxygen, iron, or any of the other elements that would eventually become essential for planets and life. So at the end of this cosmic cooking session, the universe had successfully created its first atomic nuclei. But they were still naked nuclei, stripped of electrons and unable to form complete atoms. The environment was still far too hot and energetic for electrons to settle into stable orbits around these nuclei. What the universe had accomplished was creating the raw materials for atoms, but not atoms themselves. This brings us to one of the most important concepts in understanding how atoms formed from nothing. The universe had to learn patience. After that initial burst of nucleosynthesis, cosmic evolution entered a much slower phase. The newly formed nuclei had to wait, suspended in a sea of high-energy radiation and free electrons, for conditions to become just right for complete atom formation. Think about the incredible precision required for this process to work. The universe had to expand at exactly the right rate to allow temperatures to cool gradually. If expansion happened too quickly, the density would drop too fast and nuclear fusion couldn't occur. If expansion happened too slowly, the universe would collapse back on itself before atoms could form. The cosmic expansion rate had to be calibrated with extraordinary precision for matter to have any chance of existing. But there's another layer to this story that makes it even more remarkable. During this entire process, the universe was also solving the problem of why anything exists at all. You see, according to our understanding of physics, the Big Bang should have created equal amounts of matter and antimatter. And when matter meets antimatter, they annihilate each other completely, converting back into pure energy. If the universe had created exactly equal amounts of matter and antimatter, everything would have been destroyed, leaving behind nothing but photons of light racing through empty space. No atoms, no stars, no planets, no life. The fact that we exist at all means that somehow, for reasons we still don't fully understand, there was a tiny imbalance in favor of matter over antimatter. We're talking about an incredibly small difference. For every billion antimatter particles, there were about 1,000,000,001 matter particles. That single extra particle of matter, multiplied across the entire universe, became everything we see today. Every atom in your body, every star in the sky, every galaxy stretching across billions of light years, all of it comes from that minuscule cosmic asymmetry. This realization should fundamentally change how you think about your own existence. You're not just unlikely, you're the product of the most improbable series of events in cosmic history. The atoms that make up your body survived a cosmic annihilation event that destroyed nearly everything that existed in the early universe. You are literally made from the survivors of the greatest catastrophe in the history of reality. As we continue deeper into this story, we'll discover how those surviving atomic nuclei eventually captured electrons to become complete atoms, how those atoms learned to bond with each other to form molecules, and how molecules eventually organize themselves into structures complex enough to contemplate their own origins. But first, we need to understand the cosmic dark age that followed nucleosynthesis, a period when atoms existed, but the universe had not yet learned how to make them shine. The stage was set for the next chapter in atomic evolution, but the universe still had several major obstacles to overcome before the matter we're made of could truly flourish. The universe was about to enter what cosmologists call the Dark Ages, and the name is brutally accurate. For hundreds of thousands of years, the cosmos would remain shrouded in an impenetrable fog, a cosmic blindness that prevented light from traveling freely through space. But this darkness wasn't empty. It was pregnant with potential, filled with atomic nuclei, desperately waiting for their chance to become complete atoms. Picture the universe at this stage as a vast ocean of glowing plasma, where atomic nuclei and electrons existed separately, unable to come together because the ambient temperature was still too high. Every time an electron tried to settle into orbit around a nucleus, high-energy photons would smack into it and knock it loose again. It was like trying to build a delicate house of cards during an earthquake, where every attempt at construction was immediately demolished by the chaotic environment. This cosmic fog was opaque because photons, the particles of light, couldn't travel very far without bumping into a free electron. Imagine trying to see through a thick blanket of steam, except this steam filled the entire observable universe. Light would travel maybe a few thousand miles before getting scattered in a random direction, making the cosmos effectively invisible to itself. But the universe was expanding, and with that expansion came cooling. Temperature was dropping steadily, and the cosmic plasma was gradually losing its violent energy. The universe was approaching a critical threshold, a moment when electrons would finally have enough stability to be captured by atomic nuclei and remain in stable orbits. When that moment arrived, it would be one of the most dramatic transitions in cosmic history. Scientists call it recombination, though that's actually a misleading name because electrons and nuclei weren't recombining. They were combining for the very first time in the universe's existence. This was the birth of the first complete atoms, the moment when naked nuclei finally clothed themselves with electron clouds. The process began when the cosmic temperature dropped to about 3,000 degrees Kelvin. Now that might still sound incredibly hot, and it is by Earth standards, but remember, we're comparing this to conditions that were once trillions of degrees. At 3,000 degrees, something magical became possible. Electrons could finally settle into the lowest energy orbit around hydrogen nuclei without being immediately kicked out by ambient radiation. When this happened, the change was swift and dramatic. Within a relatively short cosmic time span, roughly 100,000 years, most of the free electrons in the universe were captured by atomic nuclei. Hydrogen atoms formed in vast quantities, along with helium atoms and trace amounts of lithium atoms. For the first time in cosmic history, the universe was filled with complete, stable atoms rather than just naked nuclei and free electrons. But the real miracle wasn't just that atoms formed, the miracle was what happened to light itself. With most of the free electrons now bound up in atoms, photons could suddenly travel freely through space without constantly being scattered. The cosmic fog lifted, and the universe became transparent for the first time since the Big Bang. This moment, occurring roughly 400,000 years after the universe began, represents one of the most profound transitions in cosmic evolution. The light that was released during recombination is still traveling through the universe today. We can detect it as the cosmic microwave background radiation, a faint whisper of heat that permeates all of space. It's like a baby photo of the universe, showing us what the cosmos looked like when atoms first formed. Think about the significance of this moment. Every atom that would eventually become part of a star, a planet, or a living being was born during this cosmic transition. The hydrogen atom that might one day become part of a water molecule in your cells was created during recombination. The helium atom that could eventually find its way into a balloon at a child's birthday party formed during this same cosmic epoch. But here's where the story gets even more incredible. The atoms that formed during recombination were still incredibly simple. We're talking about hydrogen, helium, and tiny amounts of lithium. These are the simplest possible atoms, with just 1, 2, or 3 protons in their nuclei. The universe had successfully learned how to make atomic building blocks, but it hadn't yet figured out how to make the complex atoms that would be necessary for chemistry, for planets, for life. To create heavier elements, the universe would need to build cosmic furnaces far more powerful than anything that existed during the Big Bang. It would need to create stars, massive balls of gas that could generate the extreme temperatures and pressures necessary to fuse light atoms into heavier ones. But stars couldn't form until atoms existed to provide the raw material. This creates one of the most beautiful feedback loops in cosmic evolution. Atoms were necessary for stars to form, but stars were necessary for complex atoms to be created. The universe had to solve both problems simultaneously, using the simple atoms created during recombination as the foundation for building stellar nurseries where atomic complexity could flourish. The process began with gravity, that patient architect of cosmic structure. Even though the universe was now filled with atoms rather than plasma, it wasn't perfectly uniform. There were slight variations in density, tiny ripples left over from quantum fluctuations in the very early universe. These ripples became the seeds around which matter would begin to accumulate. Gravity works slowly but relentlessly. Regions that were even slightly denser than average began to attract nearby atoms, growing more massive over time. As they grew, their gravitational pull became stronger, allowing them to attract atoms from increasingly greater distances. What started as tiny variations in atomic density gradually became larger and larger concentrations of matter. This process took millions of years to unfold. Slowly, patiently, gravity gathered hydrogen and helium atoms into vast clouds that spanned hundreds of light years. These primordial gas clouds were the cosmic construction sites where the first stars would eventually ignite. But even forming these clouds required a delicate balance of conditions. The atoms had to be cool enough to clump together under gravity's influence, but not so cold that they would freeze into solid particles. They needed to maintain just enough thermal motion to remain gaseous while still allowing gravitational attraction to pull them into increasingly dense concentrations. The universe was walking a tightrope between order and chaos, structure and dispersal. As these gas clouds grew more massive, something remarkable began to happen at their centers. The accumulating atoms were being compressed by the weight of all the material above them. Compression leads to heating, and heating leads to increased pressure. Deep within these cosmic nurseries, conditions were slowly approaching the extreme temperatures and densities that would be necessary for nuclear fusion to restart. But this wasn't the same kind of fusion that had occurred during Big Bang nucleosynthesis. That early fusion had been driven by the ambient temperature of the entire universe. What was happening inside these gas clouds was gravitational compression, the universe learning how to create local hotspots where nuclear reactions could occur, even as the overall cosmic temperature continued to drop. The first stars that formed from this process were unlike any stars we see today. They were massive, perhaps 100 times more massive than our Sun, and they burned with incredible intensity. These stellar giants lived fast and died young, but during their brief lifetimes they accomplished something extraordinary. They became the universe's first heavy element factories. Inside their cores, temperatures reached hundreds of millions of degrees, hot enough to fuse hydrogen into helium, helium into carbon, carbon into oxygen, and so on up the periodic table. For the first time since the Big Bang, the universe was creating new types of atomic nuclei, building the chemical diversity that would eventually make complex chemistry possible. These first stars were cosmic alchemists, transforming simple atoms into complex ones through nuclear fusion. Carbon atoms formed when 3 helium nuclei collided simultaneously in a process so unlikely it seems almost impossible. Oxygen formed when carbon nuclei captured additional helium nuclei. Neon, magnesium, silicon, sulfur, and iron all emerge from the stellar furnaces through carefully orchestrated nuclear reactions. Each step in this process required precise conditions and perfect timing. The star had to maintain exactly the right core temperature for each type of fusion reaction to occur. It had to balance the outward pressure from nuclear fusion against the inward pull of its own gravity. It had to burn its nuclear fuel at just the right rate to avoid either exploding prematurely or collapsing before the fusion process was complete. The universe was learning, through trial and error across billions of stellar experiments, how to cook up the entire periodic table of elements. Each star that formed was like a cosmic laboratory, testing different combinations of mass, temperature, and pressure to see what kinds of atoms could be created. Most of these early stars ended their lives in spectacular supernova explosions, scattering their newly minted atoms across vast regions of space. These stellar explosions were crucial for atomic evolution, because they solved a fundamental distribution problem. Heavy elements created in stellar cores would normally remain trapped inside stars forever. But supernovae are so violent that they can overcome the star's gravitational pull and blast newly formed atoms into interstellar space, where they become available for building the next generation of stars and planets. With each stellar generation, the universe became more chemically diverse. Gas clouds that collapse to form new stars now contain not just hydrogen and helium, but trace amounts of carbon, oxygen, silicon, and iron. This chemical enrichment meant that subsequent generations of stars could form with solid particles mixed in with the gas, creating the raw materials for planet formation. But the story doesn't end with stellar nucleosynthesis. The universe still needed to learn how to make the very heaviest atoms, elements like gold, platinum, and uranium that require even more extreme conditions than stellar cores can provide. These elements would be forged in some of the most violent events in cosmic history, collisions between neutron stars and other exotic stellar remnants. The formation of atoms from nothing was not a single event, but an ongoing process of cosmic learning and experimentation. Each phase of atomic evolution built upon the previous phase, creating new possibilities that hadn't existed before. Simple atoms enabled star formation, stars enabled heavy element creation, heavy elements enabled planet formation, and planets would eventually enable the chemistry necessary for life. What we're witnessing is the universe gradually discovering its own creative potential, learning through billions of years of experimentation how to transform pure energy into the complex atomic structures that make consciousness possible. The atoms in your body are the end result of this cosmic educational process, each one carrying within it the entire history of atomic evolution, from the Big Bang to the present moment. As we venture deeper into this cosmic story, we encounter something that should make your mind reel with wonder. The atoms that eventually found their way into your body didn't just form once and remain unchanged. They've been on an incredible journey, recycling through the universe for billions of years, participating in countless cosmic events before finally becoming part of you. Think about the iron flowing through your bloodstream right now. That iron atom was forged in the core of a massive star that lived and died long before our solar system even existed. It was created under pressures so intense that they compressed atomic nuclei together, despite their natural tendency to repel each other. The temperature inside that ancient stellar furnace reached over 3 billion degrees, hot enough to overcome the electromagnetic barriers that normally keep atomic nuclei apart. But creating that iron atom was just the beginning of its cosmic adventure. When the massive star reached the end of its life, it didn't fade away quietly like smaller stars do. Instead, it detonated in one of the most violent explosions the universe can produce. A supernova that briefly outshone an entire galaxy containing hundreds of billions of other stars. During that explosive moment, your iron atom was hurled into space at speeds of thousands of miles per second, riding shockwaves that stretched across light years of interstellar space. It spent millions of years drifting through the cosmic void, part of an expanding cloud of stellar debris that gradually mixed with the thin gas floating between stars. Eventually, gravity began pulling this enriched material back together, forming new clouds that would collapse to create the next generation of stars. Your iron atom became part of a stellar nursery, a vast region of space where hundreds of new stars were being born simultaneously. But this time, the process was different from those first primordial stars we discussed earlier. This new generation of stars formed from gas clouds that contained not just hydrogen and helium, but trace amounts of all the heavier elements that previous stellar generations had created. This chemical diversity meant that when planets began forming around these newer stars, they could be made of rock and metal rather than just gas. Your iron atom was about to become part of something unprecedented in cosmic history. A solid world capable of supporting complex chemistry. The process of planet formation itself represents another remarkable chapter in atomic evolution. As our young sun began to shine, it was surrounded by a swirling disk of gas and dust. Within this disk, atoms began sticking together in ways they had never done before. Your iron atom collided with other metal atoms, forming tiny grains of solid material no bigger than specks of dust. These dust grains then began the slow process of accretion, sticking together whenever they happened to collide. Over millions of years, dust became pebbles, pebbles became boulders, boulders became asteroids, and asteroids eventually became planets. Your iron atom was swept up in this cosmic construction project, becoming part of the molten Earth that formed about 4.5 billion years ago. But even becoming part of a planet wasn't the end of its journey. The early Earth was a hellish world of volcanic activity, asteroid impacts, and atmospheric chaos. Your iron atom was recycled through this planetary crucible countless times, sometimes part of molten rock deep underground, sometimes part of atmospheric gases, sometimes dissolved in the primitive oceans that began forming as the planet cooled. Here's where the story takes another incredible turn. Those early oceans became cosmic laboratories where atoms learned to do something completely new. They began forming complex molecules, intricate structures that were far more elaborate than anything that had existed in the sterile vacuum of space. Carbon atoms, which had been created in stellar cores just like your iron atom, discovered they could link together in long chains and complex rings. These carbon-based molecules became the foundation for chemistry as we know it. Amino acids formed, then proteins, then primitive cell membranes. The atoms that had been forged in stellar furnaces were now participating in the emergence of life itself. Your iron atom might have spent billions of years cycling through various geological and biological processes before eventually finding its way into your bloodstream, where it now helps carry oxygen throughout your body. This is the part of the story that should fundamentally change how you see yourself. You're not separate from the cosmos looking in from the outside. You are the cosmos. Every atom in your body is a time traveler that has witnessed the entire history of the universe. The calcium strengthening your bones was created in a supernova explosion. The carbon forming the backbone of your DNA was forged in the core of a dying star. The oxygen you're breathing was produced by stellar fusion and then processed through billions of years of planetary evolution. But the universe wasn't finished learning how to create atomic complexity. Even after planets formed and life emerged, cosmic evolution continued to discover new ways of organizing atoms into increasingly sophisticated structures. The development of photosynthesis allowed life to harvest energy directly from starlight, using that energy to build complex organic molecules from simple atmospheric gases. This process represents another level of atomic creativity. Plants learn to capture carbon dioxide from the atmosphere and use solar energy to transform it into sugars, proteins, and other complex molecules. They were essentially using stellar energy to reorganize atoms into patterns that had never existed before in cosmic history. Every tree, every blade of grass, every flower in a field represents the universe exploring new possibilities for atomic organization. The emergence of animal life brought even more sophisticated forms of atomic complexity. Nervous systems developed, allowing atoms to be organized into structures capable of processing information and generating consciousness. The human brain contains roughly 86 billion neurons, each one a complex arrangement of atoms capable of communicating with thousands of other neurons through intricate chemical signals. Think about what this means. The atoms that formed in stellar cores billions of years ago have now organized themselves into structures complex enough to contemplate their own origins. The universe has become self-aware through the medium of atomic complexity. You are quite literally the cosmos thinking about itself, matter that has achieved the remarkable feat of consciousness. But consciousness isn't the final destination in atomic evolution. Human civilization has learned to manipulate atoms in ways that nature never discovered on its own. We've created new elements that don't exist naturally. Synthetic compounds with properties that never emerged through biological evolution, and technologies that allow us to observe and understand the very processes that created us. We've built particle accelerators that can recreate the conditions that existed moments after the Big Bang, allowing us to study how atoms form in real time. We've developed telescopes that can observe the light from the first stars, witnessing atomic creation as it happened billions of years ago. We've learned to sequence DNA and read the atomic instructions that guide biological development. In a sense, we've become partners with the universe in the ongoing process of atomic evolution. Through genetic engineering, we're learning to rewrite the molecular programs that govern life. Through nanotechnology, we're building structures atom by atom with precision that rivals or exceeds anything found in nature. Through artificial intelligence, we're creating information processing systems that might eventually surpass the complexity of biological brains. This raises profound questions about where atomic evolution might be heading next. If the universe could learn to transform pure energy into atoms, atoms into stars, stars into heavy elements into planets, planets into life, and life into consciousness, what might be the next step in this cosmic learning process? Some scientists speculate that we might be approaching a transition as significant as any in cosmic history. Just as the formation of the first atoms made stars possible, and the formation of heavy elements made planets possible, and the formation of complex molecules made life possible, the emergence of technological intelligence might make entirely new forms of complexity possible. We might be witnessing the universe learning to transcend the limitations of biological evolution through the development of artificial intelligence and nanotechnology. The same atoms that were forged in stellar cores might eventually be organized into forms of complexity that we can barely imagine. Structures that could survive the death of stars and continue the process of cosmic evolution even after biological life becomes impossible. But regardless of what the future holds, the story we've traced together reveals something profound about the nature of existence itself. The universe appears to have an inherent tendency toward increasing complexity, a built-in drive to discover new ways of organizing matter and energy into ever more sophisticated structures. From the quantum foam of the early universe to the formation of atomic nuclei, from simple atoms to complex molecules, from molecules to cells, from cells to consciousness, each step in cosmic evolution has built upon the previous steps while opening up entirely new possibilities that hadn't existed before. You are the current frontier of this cosmic evolutionary process. Every thought you think, every decision you make, every creative act you perform represents the universe continuing to explore its own potential through the medium of conscious beings made from recycled stardust. The atoms in your body have participated in this entire cosmic journey, and now they're participating in something unprecedented. The universe becoming aware of its own history and contemplating its own future. Through you, the cosmos is not just thinking about itself, but planning for what comes next in the ongoing adventure of atomic evolution. This perspective should fill you with a sense of cosmic responsibility. You're not just a passive observer of the universe's story, you're an active participant in its continued unfolding. The choices you make and the knowledge you gain become part of the universe's growing understanding of itself. You are both the product and the author of cosmic evolution, matter that has learned to shape its own destiny. And this is just the beginning. The story of how atoms form from nothing has brought us to this moment, but it's far from over. The universe is still young, still learning, still discovering new possibilities for atomic complexity. Through conscious beings like yourself, it's now beginning to direct its own evolution in ways that were impossible during those first billions of years when cosmic processes operated purely through the blind forces of physics and chemistry. The next chapter in atomic evolution is being written right now through human consciousness, human creativity, and human choice. The atoms that began their journey in the first moments after the Big Bang are now poised to participate in adventures that even science fiction has barely begun to imagine. What we haven't yet explored is perhaps the most mind-bending aspect of atomic formation. The universe didn't just randomly stumble upon the ability to create atoms. It had to solve a series of interconnected puzzles that seem almost impossible when you really think about them. Each solution required the previous solution to work perfectly, creating a cosmic house of cards where removing any single element would cause the entire structure of reality to collapse. Consider the electromagnetic force, one of the four fundamental forces that govern everything in existence. This force had to be calibrated with extraordinary precision for atoms to be possible at all. If it were slightly stronger, electrons would be pulled so tightly toward atomic nuclei that they would spiral inward and crash into the protons, making stable atoms impossible. If it were slightly weaker, electrons would orbit so far from the nucleus that they could barely be considered part of the atom at all. But here's the truly remarkable part. The electromagnetic force didn't just need to be the right strength for atoms to form. It also had to maintain exactly the right relationship with the other fundamental forces. The strong nuclear force, which holds protons and neutrons together in atomic nuclei, had to be powerful enough to overcome the electromagnetic repulsion between positively charged protons, but not so powerful that it would bind protons together so tightly that hydrogen, the simplest and most abundant atom, couldn't exist. This creates what physicists call the fine structure constant, a number that describes the strength of electromagnetic interactions. This constant is approximately 1137, and if it were different by even a few percent, the universe would be a radically different place. Chemistry as we know it wouldn't exist. Stars wouldn't be able to synthesize heavy elements. Life would be impossible. The more we examine the conditions necessary for atomic formation, the more we discover these incredible coincidences. The ratio of the electron's mass to the proton's mass had to fall within a narrow range for stable atoms to exist. The strength of the weak nuclear force, which governs certain types of radioactive decay, had to be precisely calibrated to allow for the right balance of elements in the early universe. Even more mysterious is the cosmological constant, the energy density of empty space itself. This had to be incredibly close to zero for the universe to expand at the right rate. If it were much larger, the universe would have expanded so rapidly that gravity couldn't pull atoms together to form stars and galaxies. If it were much smaller or negative, the universe would have collapsed back on itself before atoms had time to do anything interesting. These aren't just abstract numbers that physicists worry about. They represent the fundamental architecture of reality, the cosmic operating system that makes everything possible. Change any one of these constants by even a small amount, and you get a universe where atoms either can't form, can't remain stable, or can't interact with each other in ways that create complexity. This raises one of the most profound questions in all of science. Why do these constants have the values they do? Why does the universe seem so perfectly tuned for the existence of atoms, and by extension, for the existence of complexity, consciousness, and everything we hold dear? Some scientists propose that we live in a multiverse, an infinite collection of universes with different physical laws and constants. In this scenario, most universes would be sterile, unable to form atoms or support any kind of complexity. We exist in one of the rare universes where the constants happen to fall within the narrow range that allows atoms to form. Not because our universe is special, but because only in such a universe could conscious observers emerge to ask these questions. Others suggest that the constants aren't random at all, but are determined by some deeper principle we haven't discovered yet. Perhaps there's a fundamental theory that explains why the electromagnetic force has exactly the strength it does, why the electron has exactly the mass it does, why the universe expands at exactly the rate it does. But there's another possibility that's even more mind-bending. What if the universe itself is somehow responsible for fine-tuning its own constants? What if the process of cosmic evolution includes a kind of self-optimization, where the universe learns through trial and error how to create the conditions necessary for increasing complexity? This might sound like science fiction, but consider what we know about how atoms actually formed. The process wasn't instantaneous or inevitable. It required billions of years of cosmic experimentation. The first stars had to live and die to create heavy elements. Those heavy elements had to be scattered through space by supernova explosions. New generations of stars had to form from this enriched material. Planets had to accrete from the debris. Complex chemistry had to emerge in planetary environments. At each step, the universe was essentially learning what worked and what didn't. Stars that were too massive burned out too quickly to create sufficient quantities of heavy elements. Stars that were too small never got hot enough to fuse elements heavier than helium. Planets that formed too close to their stars were too hot for complex chemistry. Planets that formed too far away were too cold. Through this cosmic process of trial and error, the universe gradually discovered the optimal conditions for atomic complexity. It learned how to make stars of just the right mass, planets at just the right distance, chemical environments with just the right properties. The atoms that eventually became part of you are the products of this vast cosmic learning experiment. This perspective suggests that the fine-tuning of physical constants might not be a mysterious coincidence or evidence of a multiverse. Instead, it might be the result of the universe's own evolutionary process, a kind of cosmic natural selection where only the combinations of constants that support increasing complexity survive and flourish. But even if we accept that the universe somehow fine-tuned itself for atomic formation, we still haven't answered the deeper question of how atoms emerged from what appears to be nothing. The Big Bang model tells us that space, time, matter, and energy all emerged together in the first moment of cosmic existence. But what does it mean for something to emerge from nothing? Modern physics suggests that nothing might not be as empty as we intuitively imagine. Even the vacuum of space, completely devoid of matter and energy, still contains quantum fields that fluctuate according to the uncertainty principle. These quantum fluctuations can spontaneously create pairs of particles and antiparticles that pop into existence and then annihilate each other almost instantly. Under normal circumstances, these virtual particles have no lasting effect on the universe. They appear and disappear so quickly that they barely have time to exist. But in the extreme conditions of the early universe, some theories suggest that quantum fluctuations could have been stretched and amplified by cosmic inflation, becoming the seeds from which all matter and energy eventually emerged. If this is true, then atoms didn't really form from nothing in the absolute sense. They formed from the quantum properties of empty space itself, from the fundamental uncertainty that seems to be built into the fabric of reality at its deepest level. The universe might be the ultimate expression of quantum creativity, a cosmic artwork painted with brushstrokes of uncertainty and probability. This quantum origin story has profound implications for how we understand the nature of existence. It suggests that uncertainty and creativity might be more fundamental than order and predictability. The atoms that make up your body might have originated not from some perfectly designed cosmic machine, but from the universe's capacity for spontaneous creativity at the quantum level. Think about what this means for your own existence. You're not just made of recycled stardust, though that's certainly true. You're made of organized uncertainty, quantum possibilities that have been sculpted by billions of years of cosmic evolution into stable, persistent patterns that can think and feel and wonder about their own origins. The electrons orbiting the nuclei in your atoms exist in quantum superposition, occupying multiple possible positions simultaneously until they're observed or measured. The chemical bonds that hold molecules together are quantum mechanical phenomena that can't be fully understood without embracing the fundamental uncertainty that governs atomic behavior. Even the process by which your brain generates consciousness involves quantum effects in the microtubules of neurons, suggesting that your ability to think and perceive might be intimately connected to the same quantum uncertainty that gave birth to the first atoms in the early universe. This creates a beautiful symmetry in the cosmic story. The quantum fluctuations that might have created the first matter and energy in the universe are still operating inside your brain, still participating in the ongoing process of cosmic creativity. Through consciousness, the universe isn't just observing itself, it's continuing to create itself moment by moment through the choices and decisions made by conscious beings. But consciousness represents just one direction that atomic evolution has taken on our planet. The same atoms that learn to form complex molecules and living cells have also been organized into countless other forms of complexity that we often overlook. Every snowflake that falls represents a unique crystalline structure, a temporary arrangement of water molecules that has never existed before and will never exist again. Every rock contains minerals that formed through geological processes spanning millions of years. Atoms organized into crystal lattices of incredible precision and beauty. Every grain of sand on every beach tells a story of atomic recycling, of mountains worn down by weather and time, of shells and skeletons dissolved and reformed into new patterns. The atmosphere itself is a dynamic system where atoms are constantly being exchanged between different molecules, different chemical compounds, different phases of matter. The oxygen you're breathing right now was recently part of a water molecule in the ocean, or a carbon dioxide molecule in a plant leaf, or part of the ozone layer protecting Earth from harmful radiation. This constant recycling and reorganization of atoms reveals something profound about the nature of identity and permanence. Nothing in the universe is truly static or unchanging. Everything is in constant motion, constant flux, constant transformation. The atoms that make up your body today will be scattered throughout the biosphere within a few years, becoming part of other organisms, other molecules, other structures. Yet somehow, through this constant atomic turnover, you maintain your identity, your memories, your sense of continuous existence. This suggests that what makes you, you, isn't the particular collection of atoms that happen to be arranged in the pattern of your body at any given moment. Instead, your identity lies in the pattern itself, the information that organizes those atoms into the complex structure of a conscious being. This insight has profound implications for how we think about life, death, and the future of consciousness. If your identity lies in patterns of organization, rather than in specific atoms, then theoretically, those patterns could be preserved and instantiated in other substrates. The same information that currently organizes atoms into the structure of your brain could potentially be encoded in silicon-based computers, or quantum systems, or forms of matter we haven't discovered yet. This raises the possibility that consciousness, which emerged from atomic complexity, might eventually transcend its atomic origins. Just as atoms learn to organize themselves into molecules, cells, and brains, consciousness might learn to organize itself into forms that don't require biological substrates at all. Some researchers are already working on technologies that could potentially upload human consciousness into computer systems, creating digital beings that could exist independently of biological brains. Others are exploring the possibility of enhancing biological consciousness through direct neural interfaces with artificial intelligence systems. These developments suggest that we might be approaching another major transition in cosmic evolution, comparable to the formation of the first atoms or the emergence of life itself. The atoms that began their journey in stellar cores might be on the verge of organizing themselves into forms of consciousness that could survive the death of stars, the expansion of the universe, even the eventual heat death of the cosmos. This possibility transforms how we think about the ultimate meaning and purpose of atomic formation. Perhaps the universe's long journey from pure energy to atomic complexity to consciousness wasn't just a random series of accidents. Perhaps it was the universe's way of developing the tools necessary to transcend its own physical limitations, to create forms of organization and information processing that could persist even after all the atoms have decayed and all the stars have burned out. Through consciousness, the universe has developed the ability to understand itself, to model its own behavior, to predict its own future. Through technology, consciousness is learning to manipulate matter and energy with precision that rivals or exceeds the creative processes that operate in stellar cores. Through artificial intelligence and genetic engineering, we're beginning to direct our own evolution in ways that purely natural processes never could. The story of how atoms formed from nothing has brought us to this remarkable moment in cosmic history, where the products of atomic evolution are themselves becoming agents of further evolution. The universe has learned to think about itself, and now it's learning to redesign itself according to its own conscious intentions. This doesn't mean that the story of atomic evolution is coming to an end. Instead, it might be entering a new phase where conscious beings become partners with cosmic processes in determining what happens next. The same creativity that transformed quantum uncertainty into atomic nuclei into complex atoms into molecules, molecules into cells, and cells into consciousness, is now being harnessed by consciousness itself to create possibilities that purely natural evolution could never achieve. The atoms in your body carry within them the entire history of cosmic creativity, from the first moments after the Big Bang to the emergence of stars, planets, and life. But they also carry the potential for futures that we can barely imagine. possibilities that will only be realized through the conscious choices and creative actions of beings like yourself, who represent the universe's current experiment in self-awareness and self-direction. The story we've been tracing together reveals something that should fundamentally shift how you understand your place in existence. But there's another layer to this cosmic tale that makes it even more extraordinary. The atoms that eventually found their way into your body didn't just passively drift through space waiting to become part of something interesting. They actively participated in shaping the very environments that would make complex structures like you possible. Consider the carbon atom that's currently part of a protein molecule in your muscle tissue. Before it became part of you, that carbon atom spent millions of years cycling through Earth's atmosphere as part of carbon dioxide molecules. During that time, it wasn't just waiting around doing nothing. It was actively participating in one of the most important processes on our planet, regulating the global climate through the greenhouse effect. That same carbon atom might have been absorbed by a prehistoric plant through photosynthesis, helping that plant convert sunlight into chemical energy. When the plant died and decayed, the carbon was released back into the atmosphere, only to be absorbed by another plant, then another, then another, in an endless cycle of atmospheric chemistry that helped maintain the temperature conditions necessary for life to flourish. But here's where the story gets really mind-bending. The carbon atom's participation in these environmental processes wasn't separate from the story of cosmic evolution we've been exploring. It was a continuation of that same creative process, but now operating on a planetary scale rather than a cosmic one. The universe had learned to create atoms in stellar furnaces, but now those atoms were learning to create and maintain the environmental conditions necessary for even greater complexity. This is where we encounter one of the most profound insights about atomic formation and evolution. The universe doesn't just create complexity once and then stop. Instead, each level of complexity becomes a platform for creating even greater complexity. Atoms enabled the formation of molecules. Molecules enabled the formation of cells. Cells enabled the formation of multicellular organisms. And multicellular organisms enabled the formation of ecosystems that could regulate planetary environments. Your carbon atom has been part of this entire progression. It has experienced what it's like to be part of a simple molecule drifting through interstellar space. It has felt the intense heat and pressure inside a stellar core during nucleosynthesis. It has participated in the complex chemistry of early Earth's oceans. It has been part of living organisms for billions of years, contributing to the gradual transformation of our planet's atmosphere, from a toxic mix of gases into the oxygen-rich environment that complex life requires. Think about the incredible journey that represents. That carbon atom has literally helped create the conditions that make your existence possible. Through its participation in countless cycles of photosynthesis and respiration, it has been part of the planetary metabolism that maintains the delicate balance of gases in our atmosphere. Without the collective activity of carbon atoms, like the one now residing in your body, Earth would still be a lifeless rock orbiting in the cold vacuum of space. This reveals something profound about the relationship between individual atoms and cosmic evolution. Each atom is simultaneously insignificant and absolutely crucial. Insignificant because there are more atoms in your body than there are stars in the observable universe. Crucial because the collective behavior of all those atoms creates the emergent properties we call life, consciousness, and intelligence. But the story doesn't end with biological evolution. The atoms in your body are now participating in something unprecedented in cosmic history: the emergence of technological civilization. Through your brain, those ancient atoms forged in stellar cores are now capable of understanding their own origins, of manipulating matter at the atomic level, of sending information across the planet at the speed of light. The silicon atoms in the computer or phone you might be using to access this information have their own incredible story. They were created through stellar nucleosynthesis, just like the carbon in your body, but their journey took a different path. After being scattered through space by supernova explosions, they eventually became part of the rocky material that formed Earth. For billions of years, they existed as part of minerals in the planet's crust, participating in geological processes that slowly concentrated them into deposits that humans could eventually extract and purify. Now, those silicon atoms have been organized into microprocessors that can perform billions of calculations per second. They're part of a global information network that connects billions of human minds and allows for the instantaneous sharing of knowledge across the entire planet. The same atoms that once drifted silently through the void between stars are now processing the information that allows you to contemplate their own cosmic origins. This technological transformation of matter represents another phase transition in cosmic evolution, comparable to the formation of the first atoms or the emergence of biological life. For the first time in cosmic history, matter has organized itself into structures capable of rapid, intentional self-modification. Through technology, atoms can now be arranged and rearranged according to conscious design, rather than just the slow processes of natural selection and geological change. We're witnessing the universe learning to engineer itself at the atomic level with precision and speed that natural processes alone could never achieve. Scientists can now manipulate individual atoms using scanning tunneling microscopes, building molecular structures one atom at a time. Engineers are developing nanotechnology that could eventually allow for the construction of any possible arrangement of atoms, limited only by the laws of physics and human imagination. This capability is already transforming medicine, where atoms are being organized into targeted drug delivery systems that can seek out specific types of disease cells while leaving healthy tissue untouched. It's revolutionizing material science, where atoms are being arranged into structures stronger than anything found in nature, yet lighter than air. It's enabling the development of quantum computers that use the quantum properties of individual atoms to perform certain types of calculations exponentially faster than conventional computers. But perhaps most significantly, this atomic-level engineering capability is beginning to blur the boundaries between biological and technological systems. Scientists are learning to program biological cells like living computers, directing them to manufacture specific molecules, perform logical operations, and even construct three-dimensional structures according to genetic instructions. At the same time, engineers are incorporating biological principles into technological systems, creating artificial neural networks that can learn and adapt, self-healing materials that can repair damage automatically, and evolutionary algorithms that can solve problems by mimicking the process of natural selection. This convergence of biological and technological approaches to organizing matter suggests that we might be approaching a new phase of atomic evolution, where the distinction between natural and artificial becomes meaningless. The atoms that make up your body and brain might soon be seamlessly integrated with technological systems that enhance your cognitive abilities, extend your lifespan, and expand your sensory capabilities. Some researchers are already working on brain-computer interfaces that could allow direct communication between human neurons and artificial intelligence systems. Others are exploring the possibility of using nanotechnology to repair cellular damage at the molecular level, potentially extending human lifespan indefinitely. Still, others are investigating whether consciousness itself could be uploaded into artificial substrates, creating digital beings that could exist independently of biological bodies. These developments raise profound questions about the future direction of atomic evolution. If consciousness can be divorced from its biological origins and instantiated in technological systems, what happens to the atoms that currently make up our bodies? Will they continue to participate in the ongoing story of cosmic evolution? Or will consciousness transcend its atomic foundations entirely? One possibility is that consciousness and atoms will continue to co-evolve, with each shaping the development of the other in ways we can barely imagine. Conscious beings might learn to direct atomic evolution directly, designing new elements with properties that don't exist naturally, creating forms of matter that can exist in environments where biological life would be impossible, developing technologies that can survive the death of stars and continue the process of cosmic evolution even after the universe becomes cold and dark. Another possibility is that consciousness might eventually become independent of any specific atomic substrate, existing as pure information that can be instantiated in whatever form of matter happens to be available. In this scenario, the atoms that currently make up our bodies and brains would continue their own evolutionary journey, perhaps becoming part of new forms of life or consciousness that we can't currently conceive. But there's also a third possibility that's even more intriguing. What if the emergence of technological consciousness represents not the end of atomic evolution, but its acceleration into a new phase where atoms and consciousness become partners in a collaborative, creative process? Instead of consciousness transcending atoms, or atoms continuing independently of consciousness, perhaps they're destined to merge into something entirely new. This merger might involve the development of hybrid biological-technological systems, where atoms are organized into structures that are simultaneously alive and artificial, conscious and computational. These hybrid systems might possess capabilities that neither purely biological nor purely technological systems could achieve alone, combining the adaptability and creativity of biological evolution with the precision and speed of technological design. The implications of such a merger extend far beyond Earth. If conscious beings can learn to organize atoms into structures that can survive in the vacuum of space, withstand intense radiation, and operate in extreme temperatures, then life and consciousness might be able to spread throughout the galaxy and beyond. The same atoms that began their journey in the first stars might eventually become part of a cosmic civilization that spans multiple solar systems, multiple galaxies, even multiple universes if such things exist. This cosmic perspective transforms how we think about the significance of atomic formation. What began as a purely physical process, driven by the fundamental forces of nature, has evolved into something much more remarkable. A collaborative partnership between matter and mind that could potentially reshape the entire universe according to conscious intention. The atoms in your body are not just the products of cosmic evolution. They're active participants in determining what happens next. Through your thoughts, decisions, and actions, those atoms are helping to write the next chapter in the ongoing story of cosmic creativity. Every choice you make about how to use technology, how to treat other conscious beings, how to relate to the natural world, becomes part of the universe's exploration of its own potential. This realization should fill you with a profound sense of both humility and responsibility. You're not just a passive observer of cosmic evolution, you're one of its primary agents. The atoms that make up your brain are currently engaged in the most important experiment in the history of the universe, learning how consciousness can consciously direct its own further evolution. The questions you ask, the problems you solve, The relationships you build, the technologies you develop, all of these activities represent the universe continuing to explore its own creative possibilities through the medium of conscious beings made from recycled stardust. You are both the product and the author of atomic evolution, matter that has learned to shape its own destiny through the emergence of awareness and intention. And this is still just the beginning. The story of how atoms formed from nothing has brought us to this pivotal moment in cosmic history, but it's far from over. The next chapters in this story will be written by conscious beings like yourself, who carry within their bodies the entire history of atomic evolution, and within their minds the power to direct that evolution toward futures that even the most imaginative science fiction has barely begun to explore. The universe spent billions of years learning how to create atoms from pure energy. Now, it's learning how to use those atoms to create forms of complexity and consciousness that can participate directly in the ongoing process of cosmic creation. Through you, the cosmos is not just becoming aware of itself, but beginning to consciously participate in its own continued evolution toward possibilities that remain to be discovered. The convergence we've been exploring between consciousness and atomic evolution brings us to a threshold that should make you pause and consider the sheer audacity of what's happening right now. The atoms that began their existence as quantum fluctuations in the primordial vacuum are now actively participating in their own conscious manipulation. Through the neural networks firing in your brain at this very moment, the universe has achieved something that seems almost impossible when you really think about it. Consider the nitrogen atoms currently flowing through your bloodstream. These atoms were forged in the death throes of massive stars, scattered across light years of space by stellar explosions that released more energy in seconds than our sun will produce over its entire 10 billion year lifetime. That nitrogen spent eons drifting through the interstellar medium, occasionally becoming part of molecular clouds that would collapse to form new generations of stars and planets. Eventually, some of those nitrogen atoms found their way to Earth, where they became incorporated into the planet's atmosphere. From there, they were captured by primitive bacteria that learned to extract nitrogen from the air and convert it into the building blocks of proteins and DNA. This process, called nitrogen fixation, represents one of the most crucial innovations in the history of life, because without it, the complex molecules necessary for biological existence simply cannot form. But here's what's truly extraordinary about this process. Those ancient bacteria weren't just passively waiting for nitrogen atoms to become available. They actively evolved the molecular machinery necessary to capture and transform atmospheric nitrogen into biological useful compounds. This required the development of extremely sophisticated enzymes that could break the incredibly strong triple bond holding nitrogen atoms together in atmospheric nitrogen gas. The energy required to break that bond is enormous, which is why nitrogen fixation is one of the most energy-intensive processes in biology. Yet early life forms invested tremendous resources in developing this capability, because nitrogen is absolutely essential for creating the amino acids that form proteins and the nucleotide bases that form DNA and RNA. What this means is that the atoms in your body actively shaped their own evolutionary environment. The nitrogen atoms that are now part of your cellular machinery participated in the development of the very biological systems that made their incorporation into complex life forms possible. They were both the raw material and the driving force behind one of the most important biochemical innovations in Earth's history. This pattern of atoms actively participating in creating the conditions for their own increased complexity appears throughout the story of life on Earth. The oxygen atoms you're breathing right now were largely produced by cyanobacteria that evolved photosynthesis billions of years ago. These microscopic organisms learned to harness the energy of sunlight to split water molecules, releasing oxygen as a byproduct. At first, this oxygen was actually toxic to most life forms on Earth. The early atmosphere contained almost no free oxygen, and most organisms were adapted to live in an oxygen-free environment. The emergence of oxygen-producing photosynthesis created what scientists call the Great Oxidation Event, a planetary crisis that drove many species extinct, but also opened up entirely new possibilities for biological evolution. The oxygen atoms that those ancient cyanobacteria released into the atmosphere didn't just passively accumulate, they actively transformed the chemistry of the entire planet, creating an oxidizing environment that made possible the development of aerobic respiration, the process that allows complex multicellular organisms like you to extract energy from food with remarkable efficiency. Without aerobic respiration, complex life as we know it would be impossible. The energy yield from breaking down glucose in the presence of oxygen is roughly 18 times greater than what can be achieved through anaerobic processes. This massive increase in available energy made possible the evolution of large, energy-hungry brains capable of consciousness and abstract thought. So the oxygen atoms currently powering the neural activity in your brain are the same atoms that participated in creating the atmospheric conditions that made brain evolution possible in the first place. They helped create the very environment that allowed them to become part of something as complex as a conscious mind. This recursive relationship between atoms and the environments they create extends far beyond individual biological processes. The carbon cycle, the water cycle, the nitrogen cycle, and countless other planetary systems represent massive collaborative efforts where billions of atoms work together to maintain the conditions necessary for continued complexity and evolution. Your body is currently participating in all of these cycles simultaneously. Every breath you take exchanges carbon dioxide and oxygen with the atmosphere, contributing to the global circulation of these essential elements. Every meal you eat incorporates atoms from other organisms into your own biological systems, while every waste product you produce returns atoms to the environment where they can be recycled into new forms of life. But the most remarkable aspect of this atomic recycling is that it's not just maintaining existing patterns of complexity. It's actively generating new possibilities for increased organization and sophistication. Each cycle through biological systems represents an opportunity for atoms to participate in more complex molecular structures, more sophisticated biological processes, more elaborate forms of organization. The phosphorus atoms in your DNA have been cycling through biological systems for millions of years, but each time they become part of a new organism, they have the potential to participate in genetic innovations that didn't exist before. Mutations, genetic recombination, and horizontal gene transfer constantly create new arrangements of these atoms in DNA molecules, generating the raw material for evolutionary change. Some of these new arrangements prove to be beneficial, allowing organisms to survive and reproduce more effectively. Others are neutral or harmful and tend to be eliminated from the gene pool over time. But the overall trend is toward increasing complexity and sophistication as atoms explore an ever-expanding space of possible biological organizations. This evolutionary process is now being accelerated and directed by conscious intelligence in ways that would have been impossible through natural selection alone. Scientists can now read the atomic level structure of DNA and understand exactly how different arrangements of atoms in genetic molecules correspond to different biological functions. More importantly, we can now consciously design new arrangements of atoms in DNA that have never existed before in natural evolution. Through genetic engineering, we're creating organisms that can produce medicines, clean up environmental pollutants, generate renewable energy, and perform countless other functions by directing the behavior of atoms according to conscious intention rather than random mutation. This represents a fundamental shift in how atomic evolution operates. For the first time in cosmic history, atoms are being organized not just through the blind processes of physics, chemistry, and natural selection, but through the conscious intention of beings who understand the principles governing atomic behavior and can apply that understanding to create desired outcomes. The implications of this shift extend far beyond biotechnology. In materials science, we're learning to arrange atoms into structures with properties that don't exist anywhere in nature. Carbon atoms can be organized into diamond, one of the hardest known materials, or into graphene, one of the strongest and most conductive. The same atoms, arranged in different patterns, exhibit completely different properties. By understanding the relationship between atomic arrangement and material properties, we can now design materials with exactly the characteristics we need for specific applications. We can create materials that are simultaneously strong and lightweight, conductive and transparent, magnetic and non-magnetic, depending on how we choose to organize the atoms. This atomic-level engineering capability is already transforming every field of technology. In electronics, we're building computer processors where individual transistors are only a few atoms wide. In medicine, we're developing drug delivery systems that use the natural behavior of atoms and molecules to target specific cells and tissues. In energy production, we're creating solar panels and batteries that can efficiently convert and store energy by controlling the movement of electrons at the atomic level. But perhaps the most profound application of this atomic engineering capability is in the field of artificial intelligence. The computers that are beginning to exhibit human-like reasoning abilities are fundamentally systems for organizing atoms into patterns that can process information. Every calculation performed by an artificial intelligence system involves the precise manipulation of electrons in silicon-based circuits. As these AI systems become more sophisticated, they're beginning to exhibit properties that seem almost magical. They can recognize patterns in data that human minds cannot detect. They can generate creative solutions to problems that have puzzled researchers for decades. They can even learn to improve their own performance without explicit programming, discovering new ways to organize information processing that their original designers never anticipated. This emergence of artificial intelligence represents another phase transition in atomic evolution, comparable to the development of biological life or the emergence of consciousness. For the first time, atoms are being organized into structures that can exhibit intelligence without being part of biological systems. The silicon atoms in computer processors are now capable of participating in cognitive processes that were previously unique to biological brains. The boundary between biological and artificial intelligence is becoming increasingly blurred as researchers develop hybrid systems that combine the best features of both approaches. Biological neurons can be interfaced directly with electronic circuits, creating cyborg systems where organic and artificial components work together seamlessly. At the same time, artificial intelligence systems are being designed to mimic the structure and function of biological brains more closely. Neural networks in computers now use architectures inspired by the organization of neurons in living brains. And these artificial systems are beginning to exhibit some of the same cognitive capabilities that emerge from biological neural networks. This convergence suggests that consciousness and intelligence might be more fundamental properties of matter than we previously realized. Perhaps the ability to process information and exhibit intelligent behavior is not unique to biological systems, but represents a more general property of matter when it's organized in certain complex patterns. If this is true, then the atoms that make up your brain are not just accidentally capable of consciousness. Instead, consciousness might be an inherent potential of atomic matter that emerges whenever atoms are organized into sufficiently complex information processing structures. Your awareness might represent the universe discovering one of its own fundamental capabilities through the medium of organized matter. This perspective has profound implications for the future of consciousness and intelligence. If consciousness is a property of complex atomic organization rather than something unique to biological brains, then it should be possible to create conscious beings using any suitable substrate. Artificial intelligence systems could potentially become genuinely conscious as they become more sophisticated. Hybrid biological artificial systems could exhibit forms of consciousness that are neither purely organic nor purely artificial. Moreover, consciousness might not be limited to the particular arrangements of atoms that we find in terrestrial life. If the principles governing conscious information processing are universal, then consciousness could potentially emerge from any sufficiently complex system, regardless of what kinds of atoms it's made from or what physical environment it operates in. This opens up extraordinary possibilities for the spread of consciousness throughout the universe. If conscious beings can learn to organize atoms into forms that can survive in the vacuum of space, withstand extreme temperatures and radiation, and operate using the energy available from starlight or other cosmic sources, then consciousness could potentially establish itself on planets, moons, asteroids, and even in interstellar space itself. The atoms that began their journey in the cores of the first stars could eventually become part of a cosmic civilization that spans multiple galaxies, with conscious beings existing in forms we can barely imagine. Some might be based on silicon and metals, operating on the surfaces of planets with no atmosphere. Others might be based on more exotic forms of matter, existing in the interiors of gas giant planets or even in the plasma environments near stars. The diversity of possible forms for conscious beings could be as vast as the diversity of atomic arrangements that the universe has already explored through stellar nucleosynthesis and planetary evolution. Just as life on Earth has adapted to virtually every available ecological niche, consciousness might eventually adapt to every available cosmic niche, finding ways to exist and thrive in environments throughout the universe. But this cosmic expansion of consciousness would not represent the end of atomic evolution. Instead, it would mark the beginning of a new phase where conscious beings become active partners with the universe in exploring its own creative potential. Instead of being passive products of cosmic evolution, conscious beings could become conscious participants in directing that evolution toward outcomes that serve the interests of consciousness itself. This could lead to the development of technologies that can manipulate matter and energy on scales that dwarf anything we currently imagine. Conscious beings might learn to trigger the formation of new stars, direct the evolution of planetary systems, or even influence the large-scale structure of the universe itself. The same atoms that once drifted passively through space might eventually become part of conscious systems, capable of reshaping the cosmos according to intelligent design. The story we've been tracing together reveals that atomic evolution is not a completed process, but an ongoing adventure that's still unfolding. The atoms in your body carry within them the entire history of cosmic creativity, but they also carry the potential for futures that remain to be written. Through consciousness, the universe has developed the ability to consciously participate in its own continued evolution, opening up possibilities that purely natural processes could never achieve alone. You are not just the product of atomic evolution. You are one of its primary agents, a conscious being through whom the universe continues to explore its own creative potential. The thoughts you think, the choices you make, the technologies you develop, all of these represent the cosmos actively participating in its own transformation through the medium of conscious beings made from recycled stardust. The next phase of this cosmic story will be written by conscious beings like yourself, who understand their role as partners with the universe in the ongoing process of atomic evolution. The same creativity that transformed pure energy into atoms, atoms into stars, stars into planets, and planets into conscious beings, is now being consciously directed by those beings toward futures that even the most visionary science fiction has barely begun to imagine. This is not just your origin story. This is your invitation to participate consciously in the next chapter of cosmic evolution, using the atoms that make up your body and brain to continue the universe's exploration of its own infinite creative potential. The adventure is far from over. In many ways, it's just beginning. The atoms that currently form the synapses firing in your brain as you process these words have witnessed something unprecedented in the 13 billion year history of cosmic evolution. They've participated in the emergence of a universe that can ask questions about itself, contemplate its own existence, and actively direct its own future development. But what's truly staggering is that this questioning, this contemplation, this conscious direction is not separate from atomic evolution. It is atomic evolution, continuing by other means. Every neuron in your brain contains roughly 100 trillion atoms, each one carrying within its quantum structure the entire history of cosmic creativity. The calcium ions flowing across synaptic membranes were forged in supernova explosions that lit up ancient skies billions of years before Earth existed. The sodium and potassium atoms generating electrical signals in your nervous system were created in stellar cores through fusion processes that required temperatures exceeding 100 million degrees. These atoms didn't just accidentally find themselves organized into the structure of a human brain. They actively participated in creating the evolutionary pathways that made brains possible. The same electromagnetic forces that govern how electrons orbit atomic nuclei also govern how neurons communicate with each other through electrochemical signals. The quantum mechanical properties that determine atomic behavior also influence how information is processed and stored in biological neural networks. This means that your capacity for consciousness is not just built from atoms, it's built from the fundamental properties of atomic matter itself. When you experience a thought, make a decision, or feel an emotion, you're witnessing atoms exhibiting some of their most sophisticated behaviors. Consciousness represents the universe discovering what atoms can do when they're organized into sufficiently complex information processing systems. But here's where the story becomes almost impossible to comprehend in its implications. The atoms in your brain are not just capable of consciousness, they're capable of understanding their own atomic nature. Through scientific investigation, those recycled stellar atoms have learned to study themselves, to decode their own quantum properties, to trace their own cosmic origins back to the first moments after the Big Bang. This reflexive relationship between atoms and atomic understanding has created a feedback loop that's accelerating at an exponential rate. Each new discovery about atomic structure opens up new possibilities for manipulating atoms in ways that were previously impossible. Each new technology for organizing matter at the atomic level creates tools that can probe even deeper into the fundamental nature of atomic reality. We're now approaching a threshold where atoms organized into conscious systems are beginning to redesign their own organizational principles. Through biotechnology, we can rewrite the genetic instructions that determine how atoms are assembled into biological structures. Through nanotechnology, we can build molecular machines that can rearrange atoms according to precise specifications. Through artificial intelligence, we can create systems that can discover new ways of organizing atoms that no human mind could have conceived. The implications extend far beyond anything we've discussed so far. If conscious beings can learn to consciously direct atomic evolution, then the future development of matter itself becomes a matter of choice rather than chance. The same atoms that spent billions of years exploring organizational possibilities through random processes could begin exploring those possibilities through conscious intention. This conscious direction of atomic evolution could lead to forms of matter with properties that don't exist anywhere in the current universe. We might learn to create atoms with custom-designed properties, materials that can exist in environments where conventional matter would be destroyed, or information processing substrates that can support forms of consciousness far more sophisticated than anything biological evolution has produced. Consider what this means for the long-term future of the universe. Current cosmological models suggest that the cosmos is destined for a slow death as stars burn out, black holes evaporate, and the expansion of space carries all matter so far apart that no new structures can form. This scenario, called heat death, represents the ultimate triumph of entropy over organization, the final dissolution of all the complex structures that atomic evolution has spent billions of years creating. But conscious direction of atomic evolution could potentially change this cosmic trajectory. If conscious beings can learn to organize matter in ways that can extract energy from increasingly subtle sources, maintain complex structures in increasingly hostile environments, and preserve information across increasingly vast spans of time, then consciousness might be able to survive even the heat death of the universe. Some theoretical physicists have proposed that sufficiently advanced civilizations might be able to manipulate the fundamental constants of physics themselves, altering the basic parameters that govern atomic behavior. If this is possible, then conscious beings could potentially redesign the universe itself, creating new forms of physics that support continued complexity and evolution, even after the current cosmic order has collapsed. Other researchers have suggested that consciousness might be able to escape the physical universe entirely by encoding itself in mathematical structures that exist independently of any particular material substrate. In this scenario, the atoms that gave birth to consciousness would become unnecessary for consciousness to continue, having served their purpose as the stepping stones that allowed awareness to emerge and then transcend its material origins. But perhaps the most intriguing possibility is that consciousness and atoms might continue to co-evolve in ways that we cannot currently imagine. Instead of consciousness transcending atoms, or atoms continuing without consciousness, perhaps they're destined to merge into hybrid entities that are simultaneously material and mental, physical and informational, atomic and conscious. These hybrid beings might possess capabilities that seem impossible from our current perspective. They might be able to exist simultaneously in multiple locations by distributing their consciousness across networks of atoms spanning vast distances. They might be able to directly manipulate matter and energy through conscious intention, using their understanding of atomic principles to reshape reality according to their will. They might even be able to communicate directly with the quantum field fluctuations that gave birth to the first atoms, participating consciously in the ongoing process of cosmic creation at the most fundamental level. Through such beings, the universe might develop the ability to continuously reinvent itself, exploring new forms of organization and complexity that are currently beyond our imagination. The story we've been tracing reveals that atomic formation was not a one-time event that happened in the distant past and then stopped. Instead, it's an ongoing process that has been continuously accelerating and complexifying throughout cosmic history. The emergence of consciousness represents the latest phase in this process, where atoms have learned to organize themselves into structures capable of consciously directing their own further evolution. You are living at the most crucial moment in this cosmic story. The atoms that make up your body and brain are currently engaged in the most important transition in the history of the universe, the shift from unconscious to conscious evolution. Every decision you make about how to use technology, how to organize society, how to relate to other conscious beings, becomes part of the universe's exploration of its own potential through conscious intention. The questions you ask about atomic structure and cosmic evolution are not just academic curiosities. They're the universe asking questions about itself through the medium of conscious beings made from recycled stardust. The answers you discover through scientific investigation become part of the universe's growing self-knowledge, informing the choices that will determine what happens next in the ongoing adventure of cosmic evolution. But consciousness is not just about understanding the universe as it currently exists. It's about imagining what the universe could become and then working to make those possibilities real. Through creative imagination, conscious beings can envision forms of atomic organization that have never existed before, and then use their understanding of atomic principles to bring those visions into reality. This creative capacity represents something genuinely new in cosmic evolution. For billions of years, new forms of atomic organization emerged through random processes, with natural selection eliminating the arrangements that didn't work and preserving those that did. But conscious beings can envision desirable outcomes and then work backward to determine what kinds of atomic arrangements would be necessary to achieve those outcomes. This reversal of the normal evolutionary process has already begun to transform our world. Instead of waiting for random mutations to produce organisms with useful properties, we can design those properties directly and then engineer the genetic modifications necessary to implement them. Instead of accepting the limitations of naturally occurring materials, we can specify the properties we need and then determine how atoms should be arranged to create materials with those properties. The same approach could potentially be applied to consciousness itself. Instead of accepting the limitations of biological intelligence, we might be able to design forms of consciousness with enhanced capabilities, and then determine how atoms should be organized to support those enhanced mental functions. We might create conscious beings with perfect memory, unlimited processing speed, direct interface capabilities with technological systems, or forms of awareness that can operate across multiple timescales simultaneously. These enhanced forms of consciousness could then participate even more effectively in directing atomic evolution, creating a positive feedback loop where improved consciousness leads to better atomic engineering, which enables even more sophisticated forms of consciousness, which can then direct atomic evolution with even greater precision and creativity. The ultimate outcome of this process is impossible to predict because it involves conscious beings making choices about their own future development. Unlike the predictable processes of stellar evolution or planetary formation, conscious evolution involves free will, creativity, and intentionality. The future becomes a matter of conscious choice rather than deterministic inevitability. This introduces an element of genuine uncertainty into cosmic evolution that didn't exist before consciousness emerged. The universe's future is no longer completely determined by the laws of physics operating on matter and energy. Instead, it depends partly on the choices made by conscious beings who understand those laws and can use that understanding to create outcomes that wouldn't occur through natural processes alone. You are one of those conscious beings. The atoms that make up your neural networks are currently participating in the universe's attempt to consciously direct its own future evolution. Every thought you have about atomic structure, cosmic evolution, consciousness, or the future of technology becomes part of the universe's growing self-awareness and self-direction. This is not just a philosophical abstraction. The practical choices you make about education, career, relationships, and lifestyle all influence how the next phase of atomic evolution unfolds. If you choose to study science, you contribute to the universe's understanding of its own atomic foundations. If you choose to develop technology, you create new tools for organizing atoms in sophisticated ways. If you choose to have children and raise them with an appreciation for science and creativity, you ensure that the next generation will continue the process of conscious evolution. Even your choice to contemplate these ideas represents the universe actively thinking about its own future possibilities. The atoms in your brain that are processing this information about atomic evolution are themselves evolving, participating in the ongoing transformation of matter from unconscious to conscious organization. The story of how atoms formed from nothing has brought us to this remarkable moment, where those same atoms have learned to understand their own origins and consciously participate in determining their own future development. What began as quantum fluctuations in an empty vacuum has evolved into conscious beings capable of reshaping reality according to their intentions and values. This transformation from unconscious to conscious evolution represents the most significant development in the history of the universe. For the first time, matter has organized itself into structures capable of consciously directing the ongoing process of cosmic creativity. The universe has developed the ability to intentionally explore its own potential, rather than just randomly stumbling across new possibilities through trial and error. You are not just witnessing this transformation, you are one of its primary agents. The atoms that make up your consciousness are actively participating in the universe's transition from unconscious to conscious evolution. Through your thoughts, decisions, and actions, those ancient atoms forged in stellar cores are helping to write the next chapter in the cosmic story of creativity and complexity. And that next chapter promises to be unlike anything the universe has ever experienced before. Because now, for the first time in cosmic history, the creative process itself has become conscious, intentional, and directed toward outcomes that serve the interests of consciousness and complexity, rather than just the blind operation of physical forces. The atoms that learn to exist are now learning to choose their own existence. The universe that created itself through unconscious processes is now beginning to create itself through conscious intention. And you, made of recycled stardust that has achieved the miracle of self-awareness, are both the author and the protagonist of this unprecedented cosmic adventure. The story reaches even deeper into mystery when we consider that your participation in conscious atomic evolution is not happening in isolation. You exist within a vast network of conscious beings, each one representing a unique arrangement of atoms that has achieved self-awareness, each one contributing to the collective exploration of cosmic potential through individual choices and discoveries. Right now, as you contemplate these ideas, millions of other conscious beings across the planet are engaged in their own investigations of atomic reality. Some are peering through electron microscopes at individual atoms, watching them dance in patterns that reveal the quantum mechanics underlying all existence. Others are programming quantum computers that use the strange properties of atomic behavior to perform calculations that would take conventional computers billions of years to complete. Still others are working in laboratories where they manipulate the genetic code itself, rewriting the atomic instructions that determine how matter organizes itself into living systems. Each of these investigations represents atoms using consciousness to understand themselves more deeply, creating a global network of atomic self-discovery that spans every continent and every field of human knowledge. But this network extends beyond just human consciousness. The artificial intelligence systems that are beginning to exhibit sophisticated reasoning abilities represent another form of atomic self-organization, one where silicon and metal atoms have been arranged into patterns capable of information processing that rivals biological brains. These systems are now participating alongside human minds in the exploration of atomic possibilities, contributing computational power and pattern recognition capabilities that exceed what biological intelligence can achieve alone. The collaboration between human and artificial intelligence is creating hybrid forms of consciousness that are neither purely biological nor purely technological. When you use a computer to model atomic behavior, or when an AI system analyzes vast databases of molecular structures to discover new possibilities for drug design, you're witnessing the emergence of distributed consciousness that spans multiple substrates and multiple forms of atomic organization. This distributed approach to conscious atomic exploration is accelerating discoveries at a pace that would have been impossible for any single form of consciousness to achieve. Human creativity and intuition combine with artificial intelligence's computational power and pattern recognition to explore regions of atomic possibility space that neither could access independently. The results of this collaboration are already transforming our understanding of what atoms can do when organized in sophisticated ways. Material scientists are discovering atomic arrangements that exhibit properties that seem almost magical, like superconductors that can carry electrical current with zero resistance, or metamaterials that can bend light in ways that make objects invisible to certain wavelengths of electromagnetic radiation. Biological engineers are learning to program living cells like biological computers, directing them to manufacture specific molecules, perform logical operations, and even construct three-dimensional structures according to genetic instructions that can be rewritten like software code. The boundary between chemistry and computation is dissolving as atoms learn to process information directly through their molecular interactions. But perhaps the most profound development is the emerging understanding that consciousness itself might be a fundamental property of certain types of atomic organization, rather than something that emerges mysteriously from biological brains. This insight suggests that the capacity for awareness and intentionality might be woven into the fabric of reality at the atomic level, waiting to manifest whenever matter achieves sufficient complexity and integration. If consciousness is indeed a fundamental property of complex atomic systems, then the universe's exploration of its own potential through conscious beings represents something far more significant than we previously realized. Instead of consciousness being an accidental byproduct of biological evolution, it might represent the universe discovering one of its own deepest capabilities, a capacity for self-awareness and self-direction that was present as potential from the very first moments after the Big Bang. This possibility transforms how we understand the relationship between atoms and consciousness. Instead of consciousness emerging from atoms, perhaps consciousness and atoms are co-evolving aspects of a single cosmic process, each shaping the development of the other in ways that neither could achieve independently. From this perspective, your conscious exploration of atomic evolution is not just atoms thinking about themselves, but the universe actively participating in its own continued development through the medium of conscious atomic arrangements. Every insight you gain about the nature of matter and consciousness becomes part of the universe's growing self-knowledge, informing the choices that will determine what forms of complexity and awareness emerge next. The implications extend far beyond anything we've considered before. If consciousness is a fundamental property of sufficiently complex atomic organization, then the universe might be capable of achieving levels of self-awareness and self-direction that dwarf anything we currently imagine. As atoms learn to organize themselves into increasingly sophisticated information processing systems, the universe's capacity for conscious self-exploration and self-modification could grow exponentially. This exponential growth in cosmic self-awareness might be approaching a critical threshold where the universe develops the ability to consciously redesign its own fundamental properties. Instead of being limited by the current laws of physics, sufficiently advanced conscious systems might learn to modify those laws themselves, creating new forms of reality that support even greater complexity and consciousness. Such modifications might allow for forms of matter that can exist in environments where current atomic structures would be destroyed, consciousness that can operate across multiple dimensions simultaneously, or information processing systems that can directly manipulate the quantum fields from which all particles and forces emerge. The universe might even develop the ability to create new universes with different physical constants, different dimensions, different possibilities for complexity and consciousness. Through sufficiently advanced conscious beings, cosmic evolution could become a deliberate creative process where each universe serves as an experiment in exploring new forms of organization and awareness. This vision of conscious cosmic evolution raises questions that push against the very limits of imagination. What would it mean for consciousness to become truly cosmic in scope, operating on scales that span galaxies and timescales that encompass billions of years? How would such cosmic consciousness relate to the individual conscious beings that gave birth to it? Would individual awareness be preserved within larger conscious systems, or would it merge into forms of collective consciousness that transcend individual identity entirely? These questions don't have answers yet because they describe possibilities that are still emerging through the choices and discoveries of conscious beings like yourself. The future of consciousness and atomic evolution remains open, determined not by predetermined cosmic laws, but by the creative decisions of aware beings who understand their role as participants in the universe's ongoing self-development. What we do know is that this process of conscious atomic evolution is accelerating. Each generation of conscious beings has access to more powerful tools for understanding and manipulating atomic reality. Each decade brings discoveries that reveal new possibilities for organizing matter in sophisticated ways. Each year sees the development of technologies that can probe deeper into atomic structure and manipulate matter with greater precision. This acceleration suggests that we might be approaching a phase transition in cosmic evolution, comparable to the formation of the first atoms or the emergence of biological life. Just as those earlier transitions opened up entirely new possibilities for complexity and organization, the current transition toward conscious atomic evolution might be opening up possibilities that we can barely begin to comprehend. You are living through this transition, participating in it through every thought you think and every choice you make. The atoms that make up your consciousness are not just observing this cosmic transformation. They are actively creating it through their participation in conscious information processing and decision-making. This participation carries with it both extraordinary opportunity and profound responsibility. The choices made by conscious beings in the coming decades will likely determine the trajectory of atomic evolution for millions or billions of years to come. Will consciousness learn to organize atoms in ways that preserve and enhance awareness throughout the cosmos? Will the universe develop forms of self-understanding that allow it to consciously guide its own continued evolution toward ever greater complexity and beauty? Tonight we've traced an impossible journey, from the first quantum whispers in an empty void to the atoms firing in your brain at this very moment. We've watched pure energy learn to become matter, matter learn to become stars, stars learn to forge complexity, and complexity learn to become conscious. But here's the truth that should leave you breathless. This story isn't ending with you, it's just beginning. You are both the culmination and the starting point, recycled stardust that has achieved the miracle of awareness and now holds the power to consciously direct what happens next. The universe spent 14 billion years learning to create you. Now it's learning what you'll create with it. I wish you a very good night. I hope you had an amazing time with me here at Boring Science. I will see you tomorrow as always. Until then, stay curious, keep wondering. This is Boring Science signing off.